So good morning everyone. Today we are going to revise chapter 11, force and pressure. I hope this will help you for the better performance in your exams. So force and pressure. If we talk about force, you can see in all the pictures here on the screen. First picture, man is pushing the car, a man is pulling the cart, a hockey player is pushing the ball, horse is pulling the cart, kicking a ball. So in all these cases, what is common, you can see in all these pictures whether somebody is pushing or pulling, right? So simply we can say force is the push or pull on an object, right? If an object has to be moved, then it has to be pulled or pushed. Forces are due to interaction. Yes, this is the cause of force, the interaction between the two objects. Whenever there is interaction between one object or another, that will result in a force between the two objects. Like in this picture, you can see if the man is pushing the car from the back, then a little bit movement can be there in the car. But if the man will standing at the back without touching, without interacting with the car, then it will not move, right? So we can say that forces are due to interaction. The most important, the numerical part of from this chapter, what we call it net force. If two forces are acting in the same direction on an object, then these two forces will be added. That means the net force will be the sum of the two forces. As you can see in that A part, two forces are acting, so net force will be F1 plus F2. But if two forces are acting in the opposite direction, then it will be F2 minus F1. But you have to keep in mind, you have to keep the greater force ahead. Like the longer arrow means this is a greater force. F2 is greater than F1, so F2 minus F1. Net force is F2 minus F1. This is about the magnitude. Magnitude is the numerical value. Now the direction. Direction in these cases, first case the direction obviously will be towards left side, and in this case towards the direction of the larger force F2. Whenever the force is applied on an object, there may be some effects of force that are: force can make an object to move from rest, it can stop a moving object, it can change the speed of an object, it can change the direction of motion, it can change the shape of an object. If we talk about to move from rest, if a cycle is standing, you will push it from the back, then it will start motion. Force can stop a moving object. If you will apply in the opposite direction, pulling the car or pulling the cycle, then it will stop. Speed of object, it can increase or decrease by paddling on the bicycle. Speed can increase by stopping the paddling, that means speed will decrease. Force can change the direction of motion. Cricket player, hockey, so in these cases the direction can be changed. Force can change the shape of an object. So here in this picture you can see the shape can be changed, crushing a paper. So force may cause one or more of these effects. So either one can be there or 3, 4 can be there. Next comes the types of forces. There are two main types of forces. One is contact force, another is non-contact force. So contact forces are the forces exerted by one object on another when they are in contact with each other. Contact forces are of two types: muscular force and force of friction. Non-contact force, as from its name it's very clear that forces exerted by one object on another without any contact with each other, that are known as non-contact forces. These are of three types: magnetic, electrostatic, and gravitational. Muscular force. In all these four pictures, you can see the muscular force is applied. What is common in all these? This is force exerted by the muscles of our body. Here, the cyclist applying the force with the help of muscle, horses, the athlete, camel. So they all are using muscular force to perform various tasks. Force of friction, very, very important. We know that force is required to stop a body, force is required to move a body. When you will throw a ball on the ground or roll a ball over a surface, you might have observed, to move a ball, we need a force. After covering some distance, the ball will come to rest. So what does it show? That means there was some force which was applied on the ball in the opposite direction to stop that ball. That force which is applied in the opposite direction, that is force of friction. Very common example, if we stop pedaling a bicycle, it gradually slows down and comes to stop due to force of friction. Then comes the non-magnetic forces. First is non-contact forces, magnetic force. You can see in the picture, as from its name, it's very clear, force exerted by magnets. Right? Force of attraction and repulsion between two magnets. That is north and south. They are attracting each other. South and north attracting each other. North repelling each other. South will repel each other. So that is magnetic force. Then we have electrostatic force. We can perform this activity, very common activity, like we are rubbing a scale in our hair, dry hair. When we will bring that rubbed scale or a pencil near the small bits of paper, then these bits of paper will stick to the scale or the pencil. So electrostatic means, electro means charges, static means at rest. So in this case, we are using the charges at rest. What does it mean? It means that the portion of the scale or the pencil which you will rub on your hair, only this portion, this region will attract the bits of paper, not the full scale, right? That means the charges are at rest. They are placed where they were rubbed, where they were produced, they are stable there. This is the meaning of electrostatic. In this picture, one straw is rubbed with the hair, and then when you will bring it near the hanging straw, so it will attract. Very, very common and very, very important gravitational force. This we observed in a day-to-day life. Gravitational force. Whenever you throw something in the upward direction, it will definitely come down. Right? That is due to gravitational force. This is the force exerted by the earth on all the objects. And this object is always attractive in nature. That means it will never repel. It will always attract the things falling towards the surface of earth. Right? The leaves, the fruits, the flowers, whenever they are falling down, they will always come down on the surface of earth. That is due to gravitational force. Pressure. The term pressure itself is very, very important in science. But if as a human being we consider or we bear more pressure, like pressure of any work, pressure of studies, pressure of subject, pressure of anything, that is not good for health. But scientifically, it is completely different from that pressure which we are using in our day-to-day life. Like having a lot of work pressure, I'm having a lot of that pressure. So pressure is nothing but it is the force acting on unit area. You can see here the pressure depends upon two quantities. One is force, another is area. More force, more pressure. More area, less pressure. Because pressure is directly proportional to force and inversely proportional to area. So on this relation between pressure, force and area, there are a number of questions. Like you can see in the picture, the nail is there. At this tip of that nail, at the tip of the nail, you can see that is very sharpened, right? And in the knife, you can see one side is blunt and one is very sharp, right? Same way, shoulder bags are provided with the broad straps, not the thin straps. Why? Because they all are related to area. If we talk about nail, the lower portion is having very less area. Less area means more pressure. When you will apply a little bit force, then the pressure will be more and it will be very easy to immerse that nail or hammer that nail in the wall. Even the drawing pins which we are using for the display boards decoration, they are having the broadened portion. Why? Because if you will supply a very less amount of force on the head of that drawing pin, it will easily inserted in the drawing board. Same way, blunt knife and sharp knife. Blunt knife, it is very difficult to cut the vegetables with blunt knife. The sharp edge is having very less area, so the pressure will be more. Where if we will talk about bags, if the straps will be thin, that means area will be less, area will be small, then the pressure will be more, right? If broad straps are there, that means area will be more, pressure will be less. It will be very easy for us to carry the bags, school bags. You can check your bags, they might be having the broader straps. Even in the NCERT book, it's given that one coolie is keeping a piece of cloth over his head while carrying the luggage. Why? Because to increase the area of his head. If the area will be more, pressure will be less. And it will be easy for him to carry that luggage. Not only solids, pressure is also exerted by liquids and gases. So liquid exerts pressure on the walls of container. Liquid exerts pressure on the bottom of container. It depends upon the height. Liquid exerts sideways pressure. Liquid exerts equal pressure at same height. These are the characteristics of the pressure exerted by the liquids. You can see here in this picture, the balloon is hanged at the bottom of the open tube. When you will add the liquid, the increase in size of the balloon. When you will add more liquid, that means more height, more pressure. This picture represents more pressure, more height, more pressure. This picture represents that the liquid exert pressure or exert sideways pressure. Then liquid exert equal pressure at same height. 4 holes are there. You can check and go for the activity which I have shared on my YouTube channel. That if the holes will be at the same height, the liquid will fall at the same distance. That means liquid exert equal pressure at same height. And if you will change the holes, one hole is there, one is on the top. That means the lower portion, the water coming from the lower hole will fall far away as compared to the upper one, because the pressure in the liquid decreases with increase in height. If you will go higher, you will feel less pressure. If you will go deeper and deeper, you will feel more pressure. Same way, pressure exerted by gases. These are the examples, right? Inflating balloon and these tires, tubes which we are using, and for swimming also we are using. This is pressure exerted by gases. Last but not the least, atmospheric pressure. Atmospheric pressure, it is the pressure of air around us, very strong, very powerful. Rubber sucker you are using for the car window screens, because when we will apply the force, it will stick to the glass of the car easily, but it needs a very large force to remove that back. Why? Because of atmospheric pressure. Very common examples, drinking cold drink from straw. That is working on the atmospheric pressure, because when you will suck the air from the straw, then there will be vacuum generated, very less pressure. Outside, the atmospheric pressure will be more, so the cold drink will come in the straw. Same way it's working for the syringe. So these all are examples related to the atmospheric pressure. This picture, it's also given in the NCERT book. In the ancient time, that vessel was vacuum, no air was there, and they were joined, and 6 horses on both the sides were joined by increasing from 1, 2, 3, 4, 5, but they were not able to separate these vessels back. Why? Because of atmospheric pressure. So this is all about the presentation. Thank you very much. I hope this will help you a lot for the revision.